Understanding cleaning concentration chemistry and the ways in which it's monitored can be vital in an SMT cleaning process. An optimal concentration level can make the difference between an electric assembly that is effectively cleaned and ready to use for safe use, or one that is not clean enough, heightening the risk of faults and potentially dangerous shorts. Today, I'm excited to be joined by Kyzen's Luis Fernando Gazcon, Sales Manager for Latin America, to talk to us about why we should spend resources monitoring the concentration of our cleaning solutions and learn about the different options available to us. All right, today I'm excited to introduce Luis Fernando Gazcon, Latin American Manager for Kyzen Corporation. Thanks for being with us, Luis Fernando.
Thank you very much, Adam, for having me here in your show.
You bet. So can you start off by telling us, why do you recommend us to measure the concentration within our cleaning process?
Well, it depends. It varies depending on the type of product that you're using. We have different methods that you could use. If the product tends to split, then you need to use a method according to that. If the product can mix uniformly or homogeneously, then you can use other type of methods, which usually are more simpler.
Mm-hmm.
But it basically depends on type of product that you're using.
Okay. So how does the cleaning concentration affect the performance of the cleaner?
Well, in Kyzen, we do a lot of research and development for every product that we put out in the market. So we try different amounts of chemical combined with water. That's what we call concentration, to determine how much do we really need to clean a certain residue. So if you fall below the concentration that your manufacturer is recommending, basically what you are doing is you will not have enough chemical to solubilize those residues.
Okay.
So you will end up having either residues left on the parts, or probably you will not be able to touch it at all. So it is very important to keep those parameters between the ranges, the recommended ranges,
right,
so that you can achieve what you're looking for, which in this case is eliminate all the residues, right? It could be an oil, it could be flux, it could be, I don't know, paint, depending on what you're cleaning. So.
Okay. So what's the difference between measuring the concentration and controlling the concentration?
Well, measuring, it's, you want to know what that proportion of chemical and water is. So you can use any of the methods available, which could be, I don't know, Refractive Index, or a split kit that you can use, or conductivity meter. And that will tell you what's the proportion of the chemical and water in your bath. And controlling it, well, controlling means that you need to be adjusting the bath of your cleaning process in order to keep it between those recommended ranges. As you know, during a cleaning process, that will start to vary a lot, depending on the process, right? On the equipment. You will have drag out of the chemical, and usually that proportion starts to move. You can have also evaporation of both the chemical and the water, and also that concentration is going to move. Yep. So controlling it means you need to measure it and then do an adjustment. Adjustment means adding water or adding chemical, depending on what you need. And that will be a full control process. Basically, you can do that manually, or you can try to do it in an automatic way.
Okay. So you mentioned a couple of the different techniques for actually measuring the concentration manually. Can you tell us a little bit more about what all the options are?
Yeah, we have different options available. First, one of the common ones is Refractive Index. Refractive Index is basically you take a sample of the bath, you put it in a refractometer that will measure the light, the refraction of light through that liquid.
It's a handheld device.
Handheld, or you can have it an analog, or you can have a digital one. The analog, you put literally a drop, you see it through the light, there's a scale and you can see how much it deviates, then you need to go back and look to the tables that the supplier should provide to you so that you can have a reference of those values that usually are bricks. So what the refractometer, right, measures, it's bricks degrees.
That's the,
And you see that in a table, let's say it's 10 degrees equals 15%, right?
Yep.
So that's one of the methods. The digital one is very simple because you don't have to do that light thing. You just put the drop, it will tell you the value, and again you go to the tables.
Right.
That's one of the simpler ones because you don't need much else to know the concentration. The other one could be titration. So titration method is you take a sample of the bath, then you will need two reactives. One basically to paint that solution with a color so that you could see the change while you add the second reactive. And down there we are using the pH of the solution to see how much chemical we have on the solution. That is what we call a chemical way of reading.
Titration.
Exactly. So those are two types. We also have conductivity.
Okay.
Some products can be measured because they change the conductivity of the solution depending on the amount of the chemical in. That's another one that is very simple because you can just drop in a conductivity probe, a meter, and it will measure what. Usually it is in microsiemens, the equipment. You can see how much conductivity it is. You look in a graph and you can see how much it has varied. The other one that we also recommend is for the chemicals that tend to split. We use a split method, the kit. It's a kit where you basically take a sample, you add a reactive to separate the solvent part of the chemical from the water-based.
Yep.
And then you measure that separation. And with that, you can have a reference of how much chemical was in the whole solution.
Okay.
Usually in our case, we use a powder that you add and you need a special flask so that you can measure that separation easily. And with that separation, you go back to the tables, the reference tables, and you can see what concentration you have. All of them could get affected by the residue that you are cleaning. Once you start cleaning, the residue is going to be in the bath. So depending on that residue, you also have to choose the method that will not be affected by that addition.
Okay. And I'm assuming that your chemical supplier will be able to tell you which method is best for your application.
Exactly. That's why we have so many different methods because we have different types of chemical, different
applications.
Yes, exactly. And that's how we determine which one will be better for each process.
Okay. All right. Thanks for sharing your insights with us about manual concentration measuring. And for those of you watching, thanks for tuning in. If you like that content, make sure to hit the like button and subscribe. You can also click that bell icon to be notified of future videos. Now, if you have any questions, feel free to leave them in the comments below, or you can send an email to AskDrAdam@Kyzen.com. Also, make sure to stick around for part 2 of this episode because we have a lot more fun topics to talk about with Luis Fernando. And always remember, stay clean.